All right, what is the Ka of nitrous acid? This is a weak acid. Nitric acid is a strong acid, but this is a weak acid, so we're going to find the Ka, and we are given the pH, which makes it a little bit easier. So let's write this reaction between nitrous acid is going to lose a proton, which is what acids do. So there's a hydrogen ion, and then it's going to form its conjugate base, which is the part that has lost its the proton. And we'll set up an ice chart or an ice box. And we do that because we need concentrations at equilibrium to solve for that equilibrium constant. So I stands for initial conditions. We're given here is we're starting with 0.5000 molar of nitrous acid, and we assume before it reacts we have 0 concentration of the products. Now normally we would have to solve for X, but we're given here the pH, and remember pH is related to the concentration of hydrogen ion. So we can take the pH, or we can find the hydrogen ion concentration. It's equal to the 10 to the negative pH. Okay, that comes from the formula. pH is equal to the negative log of the hydrogen ion concentration. So if you take the anti-log and move the negative to the other side, you get what you get here. All right, so let's take out our calculators and actually wrong calculator, and punch in 10 to the negative 1.83, and the concentration of H is going to be 0.0148. Let's leave it like now. Get one more digit there. 0.01479. All right, the mole ratios are all ones, so that means we also have at equilibrium 0.01479. So that must have been the change. And if we're starting with, all right, so that's also coming from the reactants, that same amount. So to get the equilibrium of nitrous acid at equilibrium is going to be 0.5 minus 0.01479. So now we can plug this into our equilibrium expression, which is how we find Ka is going to be the concentrations of the products, which is the hydrogen ion and the conjugate base, HNO₂, over the concentration of the reactants, which is the nitrous acid. Right, and then we have that right here. That's the whole point of that ice box. All right, so 0.01479. Well, there's 2 of them, so we'll square that, all over 0.5 minus 0.01479. Let's plug that into our calculator and we should get our answer. 0.01479 squared divided by parenthesis 0.5 minus 0.01479, close parentheses. All right, so Ka is equal to 4.5. Let's see, what's the original number that they gave us? So they have 4 significant figures there. They have a pH here, but only the digits right of the decimal, the pH, because that was from a logarithmic function, is going to be preserved. So we need 2 significant figures. So 4.5 times 10 to the negative 4 is our answer.